section 13.8. It's the last section in chapter 13. Homework is on page 560, 561. You're gonna do problems 1 through 20. Okay, now this section is called standard normal distribution. We're just gonna keep building a little bit more on what we figured out so far in statistics. So we're actually gonna use the mean and the standard deviation. Okay, now here's where they use the example that I talked about a little bit last time, which is an SAT score. And I like the example, so we're gonna use it. It uses this guy Tom, and it says that he scored a 570 on his SAT. Okay, now when he took it, it was normally distributed, which I think it probably always is. I think it would be in the news if it wasn't normally distributed. But the average the year that Tom took it was a 495. And it says that the standard deviation was 102. Okay, so that means something different than if he would have gotten a 570 and the mean that year would have been a 590, right? He would have done worse than the mean. So your number is a number, but the mean and the standard deviation vary every year because it's people taking it, which means your results are going to be different. They're always going to be close. There's never been a year where the average is like a 750, but they're going to be a little bit different. So a 570 in spring of 2020 might mean something different than a 570 in spring of 2019. So you're going to get two different numbers when you look at SAT scores, and it's important to look at both of them. So what you want to calculate, which is the most important thing in this case, is a z-score, because a z-score not only takes into account how you did, but it compares it to how everybody else did. Okay, and the z-score is your number minus, remember this is a symbol for the mean, and that's standard deviation. So in Tom's case, he got a 570, the mean was a 495, and it says that the standard deviation was 102. So this is 75 over 102, which is going to be something a little smaller than 0.75. My calculator is being used to record, so we'll just go with that. And sure enough, it says in the book, it's 0.74. That's his z-score. And z-scores can tell you a lot about a value. They can tell you not only what your number was, but what that means in comparison to everybody else's number, okay? Now, the standard normal distribution, right? I said that he took the SAT test and they were normally distributed. What does that mean, okay? Standard normal distribution is this special function, which you do not have to memorize, but I'm going to tell it to you. Remember, f of x is a fancy way of saying y. That's the formula. Yes, and it's in your book. It's f of x equals 1 over the square root of 2 pi, the whole thing times e, which if you've done logs, e is the number that you do logs to. It's the log to the base e. Most logarithms are to the base e. It's in your calculator. You can use the number e, so you could plug this in if you wanted to. Off the top of my head, I think it's like 2.612-ish. And then the exponent on e is negative 1/2 x squared. Okay? Now, if you graph this function, it looks like this. Right? Graph it on your calculator, test it out. It should look something like this. Okay? And it always looks like this. And if there's handy tables, there's one in the back of the book, but you can also find them online, where it'll tell you what percentages your values are. 1 standard, 1 away from your mean, 2 away from your mean, 3 away from your mean. So you can find your z-score and you can see what percentage of the values were within that z-score, or had a z-score the same as yours or smaller, okay? So this is based on the median. Remember, your z-scores are always based on the median, so obviously 0 is going to be the most common number, because think about how you calculate your mean, which is the average, okay? So that's going to be your median, it's going to be your mode, it's going to be your average. 0 is going to be everything, okay? Now, we're going to come back to Tom, but I'm going to show you guys how to do example 1. Now, example 1 says, find the percentage of scores between 0 and 1 and between 0 and negative 2.4 in this normal distribution. So basically what they want to know is z, you're looking at z values, right? So you want to know between 0 and 1, how many scores had a z value of 0, 0.1, 0.12, something between there. Well, you can go to the back of your book on page 618, which you'll want to bookmark, and you'll see on the left is your units place and your tenths place, and on the top is your hundredths place. So in this case, we're going between 0 and 1, so you go down the left to 1 and go right across, and it says 0.3413. I'll leave that open. Okay, so between 0 and 1, it's 0.3413 of the values, which is what? 34.13%, right? Now the next one is between 0 and negative 2.4. And if I go to my table, the values for the units go between 0 and 5. There's no negative on there. Well, remember that this is a normal distribution, which means if I was to fold this graph over that 0, it would fold over perfectly. It's a mirror image. So I can just use 2.4 because the numbers for negative 2.4 and positive 2.4 are going to be the same. So again, I'm going to go down this table, and in this case I only need to use the column on the left, go down to 2.4, and the number is 0.4918. Which again is 49.18%. So that means that about 50% of your scores, not quite, right, are between 0 and negative 2.4 standard deviations. Sorry, z-scores, right? So if you double that, that means almost 100% of your scores have a z-score with an absolute value of less than 2.5. Does that make sense? So in this case, his z-score was 0.75, which makes sense, right? Because almost every single number is going to have a z-score somewhere between negative 2.4 and positive 2.4. Now, if his z-score had been 3, what are the odds of being 3, right? What's the probability that you're going to have a z-score of 3 or greater? Well, it would be really, really small, which would mean it would be a big outlier. If it was 3 positive, that would be good. That would mean he did way better than most people, or way better than he was supposed to do. If it was negative, it would mean that he did way worse, okay? But what your z-value is, how big it is, tells you how different you are from the norm. How significant is your score? This guy, his score was fine. It was good. It was better than most people, but it wasn't anything that's impressive. It wasn't, wow, look, this score was so much better than everybody else's. No, it was where he was expected to be. He did better than 75% of the people, right? But the odds of him being in there were pretty high. So let's go back to Tom's score. He has a 0.74. And if you look on the table in the back to find a p-value of 0.74, his number is 0.27, right? Which is 27%. So there was a 27% chance that he'd have a p-value that high. That's decent, right? That means it's significant. He did significantly better, but not that much better. So it just, you wanted something that's like teeny tiny. If your probability was like 1, then the odds that you were going to do that well just by luck, not by being a genius, are very, very, very small. So that's what this is telling you, right? Is just by the fact that it's a normal distribution, if you closed your eyes for all your answers and just answered, there's a 27% probability that you would have done as well as Tom. So there's a 73% probability that he's actually smart and he didn't just get lucky. Does that make sense? Anyway, what else does it say about Tom? So that means 77% of the people finished below Tom. So that's pretty good. Only 23% of the students did better than him. Now really, you want to get like 95, then you're a super genius, right? All right, now, example 2. What percentage of scores occur between negative 2.03 and 1.37? So we're looking at this standard distribution again. Let's erase what we wrote. So what percentage of the distribution of the scores occur between negative 2.03, sorry, which is like right here, and positive 1.37, so somewhere around here. So it's both of these together. Well, how are we going to calculate that? You can't do it just in one step. You have to look at the P for this and the P for this and add them together, basically. So, go back to 618. You guys are going to want to bookmark 618, okay? What was this? That was negative 2.03. That's what it was. Remember, there's no negative on the table, but it's the same as 2.03. Now, in this case, I have to go down the table to 2.0, and then I have to go across to 0.03. And that takes me to 0.4788. Then I gotta find this guy, which was I really should bookmark it. 1.37. So, again, I go down to 1.3 and then go across all the way to the 7. So 1.37 is 0.4147. And you add both of those, and then you're gonna get the odds that you were somewhere in there. So what's that gonna be? 5 remainder 1, 9, 13 remainder 1, 2, 9. 0.8935. Hopefully that's what the book has. If not, it means I did not look properly. 0.8935, right? So there's an 89.4% chance that you're gonna fall somewhere in that distribution. Now the next one is, part B says between -3 and 3. So between here and here. Should be a much bigger number, right? You're including a lot more of the population. This one's gonna be easy because the number is the same. So you just gotta look up 3, multiply by 2. Go on my table, this time I'm only looking at the left. I get 0.4987. I gotta multiply that times 2. Since I don't have a calculator, I'm just gonna add it. So it should be 0.9974. Let's see if that's what the book got. Yeah, so what does that mean? That means basically nobody, right? 1/4% of the people are more than 3, have a z-score higher or lower than 3. That means they're more than or less than 3 standard deviations away from the mean. That is a huge deal. On this side, no good. On this side, if you score more than 3 standard deviations away, you can get into any school you want, because the odds that you would have just scored like that by closing your eyes and getting lucky are less than 1/4%. It just means that you're likely a genius, so all the colleges are gonna want you, okay? Okay, example 3. And these are all just using the table, okay? And I know it seems silly, but it's so that you guys kind of get an idea of what it means when you're so many units away from an average. And the cool thing is you can use this for anything because you're using z-scores. And the z-scores depend on your average. So while you're calculating your z-score, you're including your mean, your number, your mean, and your standard deviation. So you already did all those calculations because you know how to. And then calculating the z-score works the same for everybody. You don't even have to worry about that. And then the table works no matter what your numbers are. If your average is 1,000, if your average is 500, if you had a standard deviation of 1, a standard deviation of 27, it doesn't matter what your numbers were. Once you figure out a z-score, that graph or the table always works. So for example 3, they want to find the probability that x is basically between 1.4 and 1.9 is what they're saying. Okay, so they're saying that you have this distribution. What's your probability of falling between 1.4 and 1.9? How do you do that? What page do we go to? 618, our new favorite page. You look at 1.9 and it's 0.4713. And then you look at, what's the other number? 1.4. And 1.4 is 0.4912. Okay, so how do you figure out the probability that you're going to be between them? You just subtract it. And I wrote them down opposite, so it's this minus this, which is 9. This goes down to 0, 9, 1. So 0.0199. Is that what the book got? No, they got a different number. Probably I'm wrong and they're right. But you subtract example 3. You subtract the probability of being being at 1.4 from the probability of being less than 1.9, and that's how you get your answer. And I did my math wrong, but it is about 0.0521. So, relatively small number. Example 4. Now it says, find the value for which 30% of the scores occur between 0 and A. How are we gonna do this? Okay, in this case, normally they give us a Z, and we take it to the table and we look at the percentage. This time they're kind of giving you the opposite. They're giving you this number. You gotta figure out what the Z is, right? So we can look it up though. You're still gonna go to the table. But instead of finding the percentage that corresponds to something, you actually have to look through that table and find where 0.3 is. So I'm looking, and they go up in a pattern, so you can see like at 0.9, I have 0.3159, so it's gonna be smaller than that. So I go up to the row of 0.8, and keep going, oh look right there. At 0.84, I have 0.2995. That's pretty close, right? So at 0.84, the probability of being at 0.84 is about 30%, right? You can just look it in there. Remember that it's the same in both directions. So my two answers would be 0.84 or negative 0.84. Either one of those would give me about a 30% probability. It's the same table, they're just flipping around what they're giving you. It's a little bit harder to find because it's not as straightforward, but all the numbers are still in ascending order, so you should still be able to find it, okay? But in those cases, you're not looking at the bold column and row heading. You're looking at the numbers inside the table, and you're trying to find the closest thing to 0.3 or to 0.5 or to whatever number they give you. Okay, so for your homework, you're just gonna do 1 through 20. All of those can be answered with the table. Okay, so you're just gonna get practice finding out what are the odds that you'll be so many standard deviations away, or that you'll have a certain Z score, okay? And that's it for this section.